So, good evening, everyone. See some people still taking some seats, so take your time. Good evening. So, last session of today. I hope you all had a great day today and you learned a lot of great stuff. So, what I want to talk to you about, together with my colleague here, is about serverless. It was now about 2 years ago, I think, that I first got introduced to the term invisible infrastructure. It was at a conference where we were talking about what the new things were about, the new hot topics were about for the coming year. And I was really curious about the term at that time. I already knew some stuff about function as a service. I tried some Hello World experience with that. But this idea of helping or getting some help in creating our applications where we can really focus on the business logic and really the added value that lies for our company really intrigued me. It is in that case that we as a company also did some more investigating in this topic. Now we're a Belgian company. We're mainly focused on Spring technology. We have a lot of people really experts in this domain. And so it was really nice to take a look at what can Spring do also in this topic about serverless as well. And so this is also something that we tried to figure out in this presentation. Now, as I said before, it's an interesting topic because it helps us. It can help us as a developer to create new applications. Also, a lot of companies are already more or less interested in this. And at this time, about 10% of the companies already have something to do with function or serverless architecture. And regarding to some numbers from Gartner, next year and the coming years, we will only see more and more companies interested in this topic. So there must be something going on here. Now, the thing is, we don't think that serverless will be something that you will use for every application, but it will be something like a tool on your tool belt that you can use in certain cases. And so, in fact, that's what this talk is all about. We wanted to investigate a little bit what is the proper place for using this kind of tools. And so we really wanted to get our hands dirty. Now, it doesn't really mean that you should now go home and immediately start migrating your application to a serverless environment, because that's probably not the best for every case here. And so don't try this at home if you haven't really thought about this. And experience sharing is, of course, something that can help you make a decision this way. So I hope you all get something out of this talk after today, and maybe already introduce it maybe in some specific projects, or maybe you're already doing serverless at the moment. So just out of curiosity, who is already doing a serverless application in production at this moment? Okay, some people? Yeah. All right. Now, before we get on, it's maybe good to have a good baseline to start from. What is serverless architecture? Because there are a lot of terms, terminologies, and different definitions out there. Well, in our opinion, serverless architecture is really all about two things. Namely, the first one is function as a service, where you are going to just create some code and just have it run on a platform without having to worry really about the underlying infrastructure regarding servers and things that have to be set up to make your code run. The second thing, and that is something that is not always that clear in my opinion, is that it also means that you're going to try to leverage the platform as much as possible. But because of course, if you still have to maybe set up a lot of extra stuff doing security and other services that you might need for supporting your application, then again, you're really getting away from the focus, which is, again, the business logic of your application. And so Backend as a service is really a very important part, in my opinion, as well, towards having a full serverless architecture. Now, that, of course, comes with a little costs, because it means, or it might mean, that you will tie your application a little bit more towards a certain platform. So you will have to make, of course, a decision if that's something what you want, and if that can maybe have some impact on your decision or your business. Now, we said we can just go on and keep implementing these Hello World examples, but really that doesn't give you the real value of course, creating an application that can be run, that is based on maybe an existing application, where we want to have all the functionality being translated towards serverless. And so we really got our hands dirty, and we said, why not try to migrate an existing application that we have and see what kind of problems we run into, how we can overcome them, and maybe some of them are just not a good fit. And so that was really all about this idea that we had. And so we had a typical web application with some WebSockets in there, a database, some security setup, and so on. And so we'll discuss in a minute a little bit more about the architecture. And of course, also we wanted to look out what is out there. So what kind of platforms do we have? What kind of tooling, what kind of frameworks are out there? And so we hope you can also leverage a little bit from that experience today. And so we're going to talk about some of them. Of course, also scalability is one of the ideas. We will talk about the application in a minute, where we can briefly discuss on that. And also, of course, again, because we're a company that specializes in Spring technology, we wanted to look out what is the support and Spring can help us with for creating such applications. Now, there is, of course, a risk. We are going to do a migration. So you could maybe think I'm going to do a one-on-one migration and just take everything that I have and just make sure that it runs somewhere as a function. Maybe just have one function and I just put everything in there. That's of course not a good idea. And so we really wanted to make sure that we leverage everything that is out there. And so we try to free our mind a little bit and see that we can do some investigation, what is out there, what can help us, how do we translate one thing from another, and so on. So please bear with us if we go on with this. Maybe some experimental topics might come into play here. And yeah, well, you have to be open for it. And of course, make sure to see how you are going to implement it at your company. Now, what we want to talk about today is an application which was a slot reservation system. And it's all about pigs, which you might have read also in the description of this talk. The idea is, in fact, that we have some kind of reservation website, which you can see here, where suppliers can in fact reserve some slots to deliver pigs to a food supply company. And this idea of the reservation is very particular because it starts every day at 10 o'clock. At 10 o'clock, people log into the system and are able to start reserving slots for the day after. Meaning that at that time we get a rush because people want to get the best slots. Best slots meaning in their business is apparently in as soon as possible during the day. And so you see immediately when the application starts up at 10, the first slots get reserved immediately and the other ones might get a little bit less interesting. Of course, if you don't have a choice anymore, then you have to take it. But that's the idea. And then afterwards, it's like maybe 10 minutes of reservations. And then afterwards, the application is more or less not used the rest of the day. And so this is in fact a very interesting use case where otherwise with a typical application, the application would always be up and running. With this time, we can just, when the application is not used anymore, we can just downscale. We can just say maybe just downscale all these serverless functions that we have and just don't pay for it at that time because it's most of the time not necessary anymore. There might be just one or more individuals who still visit it, but that's it. So that's the idea, and we thought about, well, that's probably a good use case to get started with. Now, if you look at the architecture for this, this is a kind of typical architecture which you might find in a lot of applications these days. And so we have a server which runs an application, which is typically layered, and we have Vaadin on the front end. We have some service layer, some repositories, and so on. All the data is stored in a SQL database as well. And so that's the application that we have here. Now, the first thing that we started with is that we wanted to move out the application, well, the front end of the application. So what we did was move out from Vaadin to a front end TIC client technology with Angular, which we started hosting on AWS S3. To be able to separate the implementation a little bit, backend and front end, we also use JSON server on the front end so that we can mock out the backend server, and so that way we could start developing the front end independent of the backend service. Now, of course, if you start doing serverless architecture, we don't think about the server anymore. But instead, we have to worry about how are we going to work out these layers that we had. So we had a service and a repository layer, including many classes there. And we have to think about what is the smallest amount of code that we want to put into a function. We're going to go into a little bit more detail later on, but it's an interesting idea because the serverless architecture already makes you think about small individual parts that can communicate with each other using a kind of an event-driven architecture. And these kind of patterns, we all know that they can help us create reusable components, which are in turn very good, of course, if you want to have loose coupling and high cohesion. So that was an interesting thing. But of course, these functions might have to operate with each other. Some functions might call other functions. And so we used AWS step functions to combine them, and we'll come back on that later as well. Underneath, you can see there that we use Terraform as an infrastructure as code. We'll also talk a little bit later more on details for that part. But it was very easy to get started that way. And we'll also see that that operation part is really crucial if you want to develop these kind of applications. And then, of course, there was this backend as a service. So we also integrated a lot of other services from AWS in this case to do all kinds of stuff like security, like database access, WebSockets, and so on. Now, again, if we take a look at our example before the migration, we had a facade which in turn would call one or more service methods, and these might then call multiple repositories. So this is, of course, the facade is like the orchestrator, you could say. Now, if we translate it, or we thought about how we translate this to AWS, to a serverless architecture. And the first thing that we thought about was, of course, we have this interface. So we are going to use an API gateway for that. So in fact, the interface itself translates one-on-one, so to say, to the API gateway. Now, the implementation of the facade methods itself, that was in fact the orchestration, and we used AWS step functions for that. So this is going to manage all the steps that we have in this kind of methods and make sure that everything is provided from one service to another, in our case, from one function to another. And so that's what we see here. And then, of course, we have our data layer. And the data layer is, well, you have multiple options there. You could say we're going to use also lambdas for that. But we decided, in fact, to package the data layer in one and multiple jars, one for each repository that we had, and make that available as a library towards our step function, well, towards our functions, using AWS layer functionality. So that way we can have a central location where we can share common libraries with our lambdas. Now, then we had to think about the programming language. And, well, the application itself was written in Java with Spring technology. So our initial idea was also, let's not try to complicate things any further. And so let's also start using Java. That way we can also reuse some of the code very easily. And of course, also because of course we wanted to use Spring technology and Spring Cloud Functions in particular for this one. We did switch a little bit towards the supportive services because those functions we have written in Node.js. And that's, of course, one of the powers that you have with these functions. You can just very easily choose the kind of language that matches your needs depending what kind of functionality, kind of knowledge that you have inside your company, and so on. So that's the approach that we chose here. Also, one of the things is typically when you talk about Java and serverless or function as a service, then well, the cold start is often a problem because it takes a lot of time to start it up. But once it's started up, it's in fact faster when you have a warm start. So that's why we chose for this. And also we can just very easily for our application preload the functions at 10 o'clock in the morning, make sure that they are hot started and that people can start using them in fact. And afterwards, if it takes a little bit longer for this one or two use cases what you have, well, it was not such a big issue at that time. And then just very briefly, we also chose for the AWS platform. As you can see, there are a lot of other possibilities. A lot of the on-premise possibilities, they focus on Kubernetes and Knative technologies, but we chose for a public cloud, in this case, AWS.
Right. So to move on to our actual implementation. So generally speaking, there's three main parts. So our BaaS, Backend as a Service, FaaS, Function as a Service, and finally operations. So in this case, I will start with FaaS because that is the main part of the application and of course the main place where all the code is happening. So the basic definition of a Lambda. So we start with Lambda, which are the functions on AWS. So a Lambda is essentially a piece of code that will run based on an input of JSON, and which in turn again returns an output of JSON. And Lambdas actually react to event sources, which can be a whole bunch of other triggers. So yeah, you've got database triggers, you've got S3, API gateway, of course. But generally speaking, Lambda is always just JSON in, JSON out. And yeah, Lambda will actually consist of a piece of code that will then define its handler by a simple string. So in this case, function.reservation.getHandler is basically just a simple class definition. So to implement our Lambdas, at least the Java ones, we used Spring Cloud Function. So Spring Cloud Function, it was chosen because it offers us to basically decouple from any specific platform. So whether it's AWS or Azure or OpenWhisk is also supported, we could basically write our code independent of any platform. On the other hand, it then also offers a very uniform programming model. And of course, it also offers us to run standalone. So we could, in a sense, just run our functions as a simple Spring Boot app and use that to, and test them locally that way. And of course, other Spring Boot features would also then be enabled because, of course, we're using Spring. So just to go over this again, so we've got our basic function definition, which may be a bean. And then we've got several cases here. So we've either got an adapter, which is an extra dependency you include to support a specific platform, or we've got the basic Spring setup, which will either become a Spring Boot app with REST support or tasks or streams or whatsoever. So I spoke about dependencies already, and these are the ones you would need. So you've got the basic Spring Cloud Function context, which is the core of Spring Cloud Function and will basically enable you to run a function, while then Spring Cloud Function adapter, in this case AWS adapter, will then start to cater towards a specific platform. So there will be there's always a small implementation cost, but usually it's simply implementing an interface without much work. Now, when we talk about implementation, of course, building is also one of the bigger issues. So in this case, we have two options. So first one would be the basic, Spring option and using Maven to build a jar. So to do this, we would build a jar, preferably using the Spring Boot Maven plugin, which would allow us to, create a jar that is instantly runnable as with Java. Something that AWS actually also needs is, however, shading, because, to improve startup times in general, it is best to actually shade all of our dependencies and place them directly in the class path. So this is just an extra step that helps with that. Specifically for AWS, again. Other option for building is actually SAM, and this is actually what we chose for in the end, but which will be expanded upon with operations. So SAM is actually was actually used to package our functions as zips. So SAM also works slightly differently from the actually Spring compiling or Maven compiling process, as it doesn't actually allow us to run the zip as a file. It's rather so that AWS will interpret that zip file and take note of the handler, which we defined earlier for the Lambda, as its entry point for the function. So again, to make it actually work with Spring, we also need an extra variable, an environment variable of main class, just to define where a Spring context exists. So again, this image. So now actually to move on one layer up, so we went from lambdas, and now we're actually going up to step functions, which are the, the orchestrating of our lambdas into one process. So here you actually have our example. So step functions are defined as a simple definition. So it's basically referring to creating a flow, a state machine of different lambdas and processes which you will execute in order or even parallel. There's a lot of options there. So yeah, and there's multiple patterns that are allowed here, such as to control the logic where you have choices and whatsoever. So in our example here, you actually see the preprocessed box, which will just perform a small change, a transformation on our input data. Then the pre-validation, which will retrieve some data which we need to validate with, the effective validation, then a choice state, evaluate validation, which will then choose, well, I go to invalid or I go to create. And then creation, which would create our effective reservation or slot reservation in our system. And then you've got notify, which will then notify connected clients of the change that happened. And here you see one of our valid flows, so moving straight through to notify, but only following one path. And finally, testing. Testing is also, of course, important. Everyone knows about, well, basic testing of microservices. So you use, in general, Java code. So you use unit tests, service tests, and hopefully UI tests. Yeah, so in general, you'll have a unit test for every class. But this testing actually becomes even slightly more skewed. So the pyramid we have here becomes rather skewed, as you see right here. So because we're thinking in serverless functions, and especially functions that have to run on a platform, it actually happens more often that we will use a function, and especially test functions and our systems on a more higher level. So where we have actually already deployed them to the system, and then test the entire flow in its entirety. This actually helps, well, because generally speaking, there are a lot more concerns here about actual hosting, or rather not so much the hosting, which is actually taken care of for us, but the actual working together of the systems. So those are extra steps that need to be thought of. So effectively, there's a paradigm shift here where we will code locally and begin testing remotely. And as Jeroen even said, testing on production. So now for a short demo. So we're just going to go through some of the code of our functions. So I've got the basic get reservations function here. So of course, our app will need to, well, retrieve reservations, and this is what will do it. So we've got, yeah, well, one sec, I'm gonna zoom a bit so all of you can see better. Right. Does that work? All right, I see thumbs up behind, so, right. So initially, well, we've got a basic Spring class. Now, this looks very basic, but there's actually two options here. Again, we could run this as a Spring Boot application. Now, you see here, we have configuration, which means it won't actually be able to run as a Spring application right of this moment. Right, so we've got a basic start. Now, this is also something different. Usually, you see your Spring application. Now, this isn't just a Spring application, it's a functional Spring application, which means it is tailored towards being a function and nothing else. What this means is, well, among others, that we're actually going to define our context ourselves. Because it is this small, it's actually, well, more efficient for boot, for startup, that we don't actually rely on component scanning and whatsoever to initialize our context. After all, it is just one function, as defined here. So yeah, this is some, well, technical mojo. Yeah, so basically just registering one bean of function registration, which will then be passed to our actual function, which then in turn is passed to our reservation repository. Defining input and output types as well. Then we have our function itself. So it'll just perform a call to our reservation repository, get reservations based on inputs from, so the in, which was a reservation query. And then finally, yeah, just definition of our reservation query itself. Now, this is actually not enough to just run this on, say, Lambda or any other platform. So we need to implement our adapter, which is what happens in a handler class. Now, you see, this is, and zoom, this is very small, and it doesn't actually need anything more than this. So we just implemented a provided interface or class from Spring, so the Spring Boot request handler, which in turn will then implement the interface needed for the Lambda, AWS Lambda system. Then, yeah, just to go over, so what we saw here again was a call to a repository. Now, we performed we used a library paradigm where every repository was becoming a separate library, and then we imported that library. So what we have here is actually just basic Spring GDBC. Again, we use GDBC templates here merely for dependency reduction, because after all, having a function run and have to load in a lot of libraries, again, is a cost for startup. So yeah, we have some basic, so create reservation and get reservation method here with each implementation, nothing special there. And then, a basic definition of the actual reservation class. So far for code demo. And then we're going to move on to the backend as a service part, which I'm going to leave to you.
Okay, so we have seen how we can create our functions now. Of course, as I said before, we have this integration with a lot of services probably as well. And the first thing, of course, that we had to do was take a look at the database. We stayed at a SQL database, but we started using Postgres, which was managed in the cloud itself, using Amazon RDS. So that was the first move we did. Of course, the migration itself from the data itself went very smoothly. And the other thing was, of course, we have to connect with that database. So we have to make sure that we get the credentials. Also for that, we had to use, or we could use AWS Secrets Manager, or we have, of course, some things like Vault and stuff like that. So you can, of course, choose whatever you like. But again, not to be stuck with managing it ourselves, we started using a managed service here as well. And then to connect everything together, the requests coming into the Lambda functions and the step functions, we chose to use API Gateway for that. And for security reasons, of course, we also made use of Amazon Cognito, which is in fact also making sure that our WebSocket is securely. And as you can see, the client itself is going to request a token from that service. And then, of course, with every request, we provide this token, which is then going to be checked against the service itself for validity. Now, the only thing that we had left to do was keep some more state. As we said before, the serverless application itself can be started very easily and very quickly, but can also be shut down, so we can't really store anything in them. And so, of course, for being able to store all the clients that were connected towards our application so that we could send updates, we had to store them externally from the functions, and we chose Amazon DynamoDB for that, and together with the Lambdas itself in Node.js. So every time we get a reservation, it's going to check DynamoDB for all the connected clients, and it's going to contact the API gateway to send out a WebSockets message towards those clients. Now, a thing about operations maybe before we continue, because you might think that serverless now means we don't have any operations at all, but that's of course not true. In fact, sometimes it can make it a little bit harder. Of course, you don't really have to care about the management of the service anymore, but a distributed application comes with a lot of extra things that you have to take care of. So you have to make sure that you have distributed monitoring, for example, so that if something goes wrong, you can very easily figure out where the fault is happening. Of course, other things like security, you have a lot of things going on regarding logging and so on. So there are a lot of things that you have to take care of, which are still your responsibility. And you can, of course, use some tools for that, but that's, of course, it's not gone away. Now, for the operations in the sense of infrastructure as code, we started with Terraform, and this is in fact helping us to set up our infrastructure, our resources that we need for this environment. And it's a multi-platform infrastructure as code, meaning that you can have one template that contains resources for different platforms. And also it's going to store the state independently of the platform, meaning of course that it's going to check out what kind of resources are already deployed at that time, so that he doesn't, well, that he can be very smart in only doing the updates and not having to redeploy everything all the time. Now, one problem that we encountered here was that at a certain moment we started to implement the WebSocket support, and so we had to use the API gateway for that, and that was in fact not yet supported in Terraform at the time. And that's of course because Terraform needs to keep up to speed with all the platforms and the new functionalities that come out there, and they can run behind a little bit. And so that's one of the problems that we discovered with Terraform. And later on, in fact, well, one solution could be, of course, that we have one Terraform file for most of the things, and then just one CloudFormation, for example, for that. But that's, of course, doesn't really feel right. And so later on, we in fact switched towards CloudFormation entirely to do our infrastructure as code. Also, SAM, as I said before, is going to help us with the building. So it's doing the build automation, but it's doing a lot more than that. It can also help us to do local testing. Local testing with some mocking, not that much, but you can mock the API gateway, for example, and you can also have a local DynamoDB instance if you want to. In the end, we didn't really use this a lot because of the fact that it's only going to work if your API gateway is rather simple. But in our case, we had to define our own API gateway setup because we had this WebSocket support and so on that is needed. And there's also some built-in best practices. For example, you can do gradual deployments, where you say, I'm going to direct the 10% of the traffic towards a new version of my function, and if everything goes right, then we can do more. But if maybe some alert pops up, then automatically we can roll back to the previous version so that we can find out what's going on. So in fact, SAM uses its own templating ID above CloudFormation, meaning that he's going to translate his SAM template into a CloudFormation one. On the left side, you can distinguish the SAM template because there is a transform element in there, meaning that AWS is going to have to do a translation step towards CloudFormation there. And then you can have your resources. As you can see here, we define a function for getting the reservations. It's based on a runtime Java 8, and it has a link towards the API gateway with a path/reservation and HTTP method get. And so that way we define all our resources, and we can start deploying this into our environment. Now, in fact, for our rather simple example here, you can see that there's already a lot of things going on here. And the main thing I want you to notice here is that, of course, you don't really want to set this up yourself through the console. This needs to be automated as much as possible. This is a small application, but if you start using this for larger applications, then this is really mandatory to have it automated as much as possible. And you can see some numbers up there regarding our stuff. And then, of course, one template that rules or manages them all. Another couple of things which we're not going to go into much detail here, but of course you also need to take care of CI/CD. We are looking at this moment at AWS also for some support in that one because it has nice integrations with SAM. And also monitoring, of course. We have default monitoring with CloudWatch, but we're also looking into more detailed logging towards AWS X-Ray, which is going to help us with that as well. And I think that's bringing us to a final demo.
Right, so for the final demo, I'm actually going to take you all through the console and show some of the, well, essentially resources that we've now deployed using our SAM template. If I find it, there it is. Yeah, so let's just start off at the bottom. So we've got a function essentially here. So this is the Lambda console. We've got several functions here. Most of these are actually Node, yes, as you can see. But we've also got a couple in Lambdas. And I'm just going to grab one. So the get reservation function, which we showed earlier. And this is actually all that it is. So right here, you've actually got plenty of options. So you can perform tests at this point. We can also just run, change some parameters on this. But this is all managed for us. So right now, we've actually just taken this, put this all of this in our template, our SAM template. And as such, it just appears here for us. This is, of course, useful if you have to debug or there's any errors or whatsoever that happen. Of course, this is the place to go and actually find what's happening. Now you'll notice some specific things. So first of all, as I said earlier, there's some specific needs we need because we're building a Spring app with SAM. One of those would be the main class. I'm actually going to zoom in a bit. So one of those would be the main class, which now defines which class actually contains our Spring context. Another would be function name, which is actually required to define the bean that Spring is going to assume as the function to be run for this Lambda. So it would essentially be possible to, for example, combine multiple functions in one jar and then deploy them all together and define which one should run with this parameter. Also some other stuff. So secret names, which is for the secrets manager, which was mentioned. And then, yeah, just a gDBC URL for a database. Moving on to step functions. So here you actually see in small our entire process. I'm going to close this. So this is the definition of our state machine. So you see a whole bunch of states defined. Now again, this might differ for platforms. So, well, Step Functions uses this. But again, Google Cloud Functions or Azure may have their own implementations for this. And yeah, so this is a whole flow that is defined, which effectively evaluates to this graph. So yeah, so we got, again, I went over this, so pre-processing, retrieve, revalidate, validate, etc. And I'm actually going to perform a quick run to also show something else. So let's see. If we go here, we'll look at our execution. So you see we've got a bunch of them. I'm going to copy this one, change one parameter, because things need to be different for validation to work. And we're just going to start this. And we're actually going to see live how this is now running. So yeah, this is effectively live now. So we've got a function running, or several functions. And you can actually see the process of startup here. So there's actually two states for a Lambda to be in. It's either hot or cold. Okay, not the Katy Perry song. But yeah, so hot would mean a Lambda is actually already active and running in an existing machine. While cold would mean it is currently inactive and needs to start up first. That's a so-called cold start, which, as you see, is occurring now. So this Lambda took a while. I mean, it isn't written in Java, which means cold starts will take longer than, for example, an interpreted language Lambda written in Node or Python or whatsoever. But then again, we've got the advantage of, because it's actually compiled language, it will run faster once it's started. So yeah, we'll see this flow going through now. So yeah, we went through validate and now create, which again is starting up. And this is actually also a very useful UI because we can actually click on each of the states and look what was inputted and what came out right here. So create has finished and now notify is running and notify is done and our flow has completed. And then now I'm actually going to just run the same code. So this should now fail and show our failure flow as such. And you'll see it's actually already finished because each and every one of those lambdas was now actually already active and as such could just be accessed immediately. And finally, we've got our API gateway. So the API gateway, which perhaps wasn't explained very well, but is essentially our port to the internet. So if our front-end application wants to access this one, it will actually arrive here, and then from here on out, we can send messages, parse HTTP requests, and send them to the appropriate function or step function that they have to go through. And then finally, and I've actually forgot to open this, so you're going to see some more internals here. We have our actual front-end application, which is hosted in a simple bucket on S3. And if I go into properties over here and over here, and then reserve, and then we actually have our ready-made application right here. And if we say click, and well, right, I actually need to use the buttons, validation, right, and reserve, and then we should receive a message here. hopefully, I assume. Demos, they never go right. Again. Yeah, so apparently this one doesn't want to work right now, but, well, I guess something has to go wrong. So anyways, that would be then the end of the demo. I hope you all enjoyed. And let's go on to our conclusion. So.
Okay, so. All right, so we still have a conclusion, but you can. Well, they have already clapped, so you can just leave after the conclusion, no problem. So just to summarize some things up here, this was not really a walk in the park as maybe we would have expected it to be. There is a lot of things going on here. This is a distributed application. We know that from microservices, of course, and there's a lot of things going on there. Of course, when you make it more granular and put it on the function level, then of course that complexity can only increase because you now have more things to manage. And in fact, the management is still one of the things that are, for this kind of application, quite simple. But again, if you have large applications, figuring out what is the capabilities that you have in your application is kind of like a real thing that you have to care about. So that especially if you have a large development team, that everyone knows what kind of functions you have available, what kind of capabilities are in there, how can we retrieve them, how can we find them, and so on. Also, we experienced that there is some documentation available, of course, but there is not that much guidance in best practices and how to handle things. There are, of course, some frameworks that already have some kind of idea about this. Well, we didn't actually look at the serverless framework, but it is one of the things that we want to look at. And of course, we just looked at SAM, which is already giving us some direction, but still there's a lot of work going on there and a lot of things that can improve, in my opinion. Also, the operations, especially for deploying with multiple versions and stuff like that, that is something that SAM can handle, but still to propagate changes towards different environments and stuff like that, you most of the time have to do a lot of manual setup still. Now, the idea of this architecture is kind of neat. As we said before, it forces you to think about these small units that communicate with each other, but it also have some, you have some responsibilities there as well to make sure, of course, that the things that are valid for a distributed application, that you also apply them here. Things like idempotent, stateless transactions, stuff like that. You also have to think about this because it's not very easy if you just neglect these kind of things. But then again, you can make use of reusability because now you have these different functions that you can just start using in different step functions. For example, using these state machines. Our idea, if you want to go and look into this, try to focus on one platform to start with because it's easy to get lost. We as well, in preparation for this talk, started to look in all kinds of stuff, and we really wanted to make this about the entire architecture. Well, you're going to get lost anyway at that time. So start small, start with one platform, use one tool to build your stuff, and then go from there. That's a very good idea to start with, I think. And as I said before, you still have to think about operations. If you're not doing operations right now, or you're not really into the DevOps part, you really are going to be forced to do it. If you don't have to, or if you don't handle your microservices at this time in a proper way, with all the operations that come along with it, you're not going to do it good in a function as a service platform, because it's going to get even worse there. So start looking into those things. And then of course, for the code itself, well, the language is really up to you, of course, depending on what you are used to maybe. But again, you have this very flexible way of defining multiple languages, and you can combine them just the way you like it. So make use of that as well. So mix if you need to. But of course, as we are really focused on the Java language, it is a nice language, but keep in mind, of course, this idea of the cold starts, which might be an issue for some applications. So I think that concludes our talk. So are there any questions at this moment? Yes, in the back. Sorry, can you repeat again?
Can you check X-ray to know? Okay. Can you check X-ray to know what happened to the application? Just to give us.
Well, we actually haven't got X-ray configured right now, but I could check CloudWatch to see what's going on there. if you absolutely want it, hold on.
So that's one of the things that we're still looking into more detail. So at this moment we're using mainly CloudWatch to monitoring everything, well, the basics of our Lambdas. But the X-ray is allowing us to go even further. So we briefly looked into it, but we have not really rolled it out for this application at the moment. Yeah. So. So while Wim is looking that up, maybe.
Yeah. Next question. no, I'm doing it.
Here. Why AWS? Was it a technical decision or was it given somehow?
I'm still not seeing who's talking, but oh yeah, there. Okay. Hey, yeah. Well, it was more or less like a decision of multiple things. First of all, we had some experience already in the platform because last year we also did an application there using AppSync, which is in fact an abstraction on top of serverless. And otherwise as well, because there is good community out there and most of the time good documentation as well. Well, it's sometimes you run into some troubles, but I think the other platforms might even have it more difficult there. So that were the main two reasons that we looked into AWS at this time. But when using now the abstraction that we have in Spring, we should be able to transfer the functions very easily, in fact. So if one time we find out that another platform might be better at the time, we can just very easily swap that out. Of course, the services might be a bigger problem because, of course, they will have to be reconfigured and see what we have there. Yeah.
Right, so to answer the previous question, I don't know. Okay. It works now, but yeah, we have noticed this earlier that when call starts happen, sometimes, well, the actual response in the front end doesn't work that well, and it isn't handled as such. But yeah, generally speaking, our function does work fairly well. But the functions work, but the front end may need some improvements. So again, that wasn't the focus.
I have another question. Why are we forced to test the Lambda function directly in AWS? If we are using a Spring framework, we can create a kind of integration or a unit test, I guess.
True. It is possible to perform certain mocking and such to actually integrate and test in just locally. That's true. But in the end, it's mostly because the actual environment we're running on might change some things. So for us, it would actually be that we actually had to perform trial and error to actually get a SAM-built Spring function actually working on there. So certain things that might not be thought about, such as the main class environment variable, were needed to get it to work, and weren't actually, we didn't find it documented anywhere. So that was one of those things, and it might just be something that happens, and if you don't test it on the platform, then you might come across surprises when you actually do go to production.
I think it's also, it can deviate a little bit. So the mocked API gateway, for example, that you have with SAM locally is not necessarily the complete counterpart of the one that you have running in the AWS account. So also there you have to pay attention. But I think it's a good practice, of course, if you can try to do as much integration tests locally, because they are rather cheap to do, of course. But again, you will have to, in our opinion, have to deploy it once to a platform to then, of course, make sure that everything runs there.
So what are these change some things? That's a little vague about like what's actually going to happen. What things could the AWS actually change for your functions?
Well, it's not so much that AWS changes the function, it's more so how it runs it. So where Spring or Maven would generate a jar which would then run on a platform, it could even run on AWS. It's more so that, how SAM builds, so AWS SAM builds our function is in the form of a zip. And it actually just, drops our classes in, a fairly simple format into the zip, as well as all dependencies needed. The way it works is that, in that form, AWS will actually look for our handler, which we defined for the function, in there. And then the handler will be initialized, booted up, and we'll then start looking for a Spring context. Now that's where it would actually go wrong, because it couldn't find one since it wasn't booted up as a normal Java Spring app. So that's where that went wrong for us. So yeah.
That was the main problem that we discovered. At this moment, I think the rest of the things looks really good to test it locally first. But that was one of the problems that we ran into.
essentially the code is still the same. It's more so how it is run and what the entry point to the code is. So yeah, and how it started up in that sense.
Okay. So yeah, maybe just one more question. Yes, please.
Do you keep all of the code for your functions in a single repository? Do you have a repository for functions?
Yeah, so we do use a single repository. Well, for mainly ease of ease of versioning and whatsoever. Although we do have. Turn it off. Right. So to continue. Yeah. So as I was saying, we do have everything in the same repository, but we do use submodules in this case, and well, a Maven parent-child structure to actually organize our functions. Yeah.
Okay. So we're out of time, I see. So thank you very much. So if you have more questions, please come and talk afterwards. And so have a great conference. Thank you.